I'd like to invite any of our participants who would like to offer a comment. And as you go to the mics, I'll just make a few other remarks, if I may. One of the things that impressed me in the course of this day is that we've been talking about, I think, two very closely related but distinct connected elements. The rigor of science, that is the ways in which science is conducted at the highest standards, and the transparency of science, that is the way in which science is reported and recorded in ways that others can understand thoroughly, fully, and completely what it is was done and how it could be repeated and tested by a second scientist. So those two connected ideas, I think, are important for us to bear in mind, because as I listen to a number of the suggestions and ideas that we've talked about, some of them, it strikes me, really focus on enhancing the rigor of the scientific exercise. Some focus specifically on enhancing the transparency of the scientific enterprise, and some actually talk about the intersection. And I think it would be helpful if we kept in mind those distinctions and connections as we think about the roles of these particular constituents that we've been asked to think about. And secondly, I guess I would say that one of the other templates or organizational principles, and Brian, I see you're in line, so I'll be eager to hear your further reflections, but it did seem to me in the hierarchy that you described of essentially making it possible, making it easy, making it the norm, making it rewarded, and making it required, if I remembered correctly from the range that you talked about. I think it would be very interesting for us as we thought about possible interventions to identify where in that hierarchy are we targeting any particular idea. So if we could, as we think about the key constituencies, namely the researchers themselves, the institutions that educate and support them and receive the money, the funders who support the research, and the publishers and editors who end up reporting to the larger scientific community. If we think about the roles of each of them, we think about what they could do. So we would answer a question in the form, if actor X, if institutions did action A, whatever we now suggest, then this is what we believe could follow. And I think if we try to approach our task in that way, it could be a really well organized, systematic way for us to collect our best thinking about these ideas. But now let's turn to those of you who are here, and we'll start in the middle and then move to the other if there are others at the other side. So go ahead.
Children's Mercy, Kansas City. This is for Valda, a follow-up, and we discussed this one-on-one, but I just want to get it on record. It's actually unethical to conduct a bad animal experiment. It's against all principles of animal research. Comes up frequently. I've been asked to add in a classic PDX model, and I explain there is no such thing, it doesn't actually work, and no, I'm not going to do it, which often leads to the obvious consequences. An underpowered study, an inappropriate model, I think the journal editors can actually intervene in these situations and say, you know, we're not going to ask for that because it's unethical. In contrast with clinical trials, at least the patient has to consent. The animals don't have a choice.
Right. I mean, just to be clear, you know, we would not publish an animal study that we thought that we knew was a poor model, underpowered. You know, we are often reliant on reviewers. It's the editor doesn't have the expertise to make these calls, and so if the reviewer says, do this animal study, the researcher goes and does the animal study, it comes back and the reviewer says it's okay. I mean, I think that we're moving into a different time where there is a heightened awareness. And so we are we have brought on more statistical review. So that is finding problems that we maybe would not have found before. And so I think that, under this, as we raise the bar, because that's essentially what we've done, essentially we're saying, okay, we're raising the bar, it's going to have to cross these thresholds for us to publish it. We're getting to be a place where we are really asking a lot. And so I think we just do have to rethink what is a paper. And of course, in some cases, it's a preclinical paper, and the whole paper, and the paper, the animal studies are critical to the paper. So I'm not saying, we absolutely support good preclinical study, and we don't want to be in a position of publishing bad studies, but I think it is a learning process.
Thank you for the question and for the very helpful comment. Please.
Michael Kaiser, UCSF. And so a topic I wanted to pick up on that I've heard a lot today, and I know that Franklin, you referred to, and others, is burden. We've been talking about who is going to bear this burden. And across the board, everyone has very good reasons why we're already bearing lots of burdens. Scientifically, that's the world we're in. And so asking anyone to take on more of it seems hard. And so borrowing ideas from other fields, I want to bring in one other concept before I propose a couple answers, which I look forward to you tearing apart, hopefully. One of them is no plan really survives contact with the enemy. No way that we put guidelines down will cover all of the situations that we anticipate. Checklists will be essential and are great for getting the plane perhaps initially off the ground, but there are other cases where we've had to deal with complex situations and we've had to try to break them. So one example is cybersecurity. And in that case, you can put together things with all of the best guidelines. And yet, for whatever reason, in the implementation, in the libraries of the software, in the physical hardware, any of these things, there's a flaw, despite the best intentions. In cybersecurity, you have bad actors, but you have good ones too. And so within your own institution, or with a company that you would hire, there's a notion of a red team. And the red team's job is to break the system, and preferably break it at home, or at least be an adversary that's not a bad actor. To your comment, Franklin, about what are the other groups? What are all of these people who are coming through our PhD systems? Perhaps there's a role for red team. If we have data scientists, what about data breakers? Who should be responsible for this? And my answer in that case is all of us, but there should be red teams. Right now, the equivalent of red team is more like the hacker. I go and I look at someone else's paper, maybe because I care a lot about this field, and I find a problem with it. Generally, I contact them. We might disagree. Eventually, we go through a process of commentary or public back and forth review. That works, but it takes a lot of effort to be on that side of it, and it might take half a year or more before that comes out. Just a couple random ideas. I know the NIH is interested in bug bounties, and so if you can find bugs in systems, and this is an early idea, just talking offline, then that could be a way for either public recognition in a positive sense, or perhaps even some funds behind that, as is done in the cybersecurity communities. Talking about training grants. Who is the perfect person to attempt reproducibility? Perhaps second, third year trainee in the field of their interest. As a training grant requirement, perhaps it would be interesting to have trainees provably attempt reproducibility. They might succeed, they might fail, but having that on record as part of the didactic process is something that already we have certain requirements of trainees. Already we have concerns, are we training our trainees well enough? What is rigor and reproducibility there? Try it out. And so that's just another thought as well. And so with that, I'm curious if you have comments on it. Thank you very much.
Thank you, Michael. Hands-on science in a different mode. Any comment anyone wants to offer? Shall we hear additional words? You want, Frank?
I would just briefly say that we had been talking earlier about the sort of pipeline of graduate students and postdocs who aren't going to end up in faculty positions, and that this is a perfect role for them, and that administratively we have, whether it's the library or whether it's the Office for Research and various other roles, there's administrative places to put those people and have them support research. There's a lot of education projects on campuses to teach reproducibility to faculty and to researchers. That has to happen. But I actually think we should take the job kind of away from them in certain ways and give it to a new set of professionals whose job will be to do a lot of these pieces required for reproducible research, because the burden issue. It's just too much to ask someone to be a subject specialist and be an expert in scholarly communication and be a programmer and be a computer scientist and do all of these things.
Comment too about reproducibility and replication of studies is that bores me. Like I'm in science for discovery, and the idea of like replicating another finding is not interesting. Now I do it in the context where I'm trying to add a new model into our lab, but those are really small replication studies. Never, even if it failed, I wouldn't be able to publish the failure because it's such a small little thing. And so I think that's something to keep in mind too when we're thinking about this, is that not a lot, I mean, there are probably some, but not a lot of scientists are really excited to replicate data, right? You want to go out and test new hypotheses and discover things, but for what that's worth.
Universities.
Yeah, you're right.
I'd like to comment on behalf of Mike Lauer, who was an earlier speaker, that one of his jobs is to work on burden reduction. And so he doesn't always try and invent new ways to burden us. And any ideas that you have for burden reduction, it's one of the things he wants to implement.
That would be a really wonderful contribution if we can make that, Richard, for sure. Please.
Brian Nosek, Center for Open Science in University of Virginia. Panel was great, lots of interesting comments. In the spirit of going from potential actions to what potential consequences, I think Valda's example is a perfect one to think about this, because it's such a stress point, because it's so common, right? The reviewers say something's interesting here, but I'm not convinced enough, there isn't enough here. And the authors now have the pressure point. I want that outcome. This study has to do a certain thing in order for me to get that outcome. And so I think it's worth thinking about what could we do at intervention right there. And you offered one solution, which is just not have to require them to do the next thing. I wonder if you'd consider also this as a perfect spot for a registered report. So they've submitted the paper. They need to do something additional. The registered report would be, you need to do this additional experiment. Submit the design and the protocol. We'll review that, and then we'll commit. Whatever the outcome, we'll publish the paper. Just doing that would remove the pressure from the researcher to then have to get the result to get it in the journal. But the journal has committed, this is interesting, and it'll be useful to find out. And even better than just committing to that, how about do it as a randomized trial, where you do it as current practice, just go get the result, or they get randomly assigned to doing it as a registered report. And then we'd really find out if it reduces the likelihood of positive results coming through and the reproducibility of all the results. That would be an awesome study.
I can see Valda taking notes.
I like
what do you
that,
think?
Yeah. I'm not going to, well, we have one editor-in-chief leaving and another one coming, so yeah. No, that's an interesting idea. I mean, I think if we really went there and we wanted to do something sort of randomized, I don't think we have the numbers alone, so I think it would have to be bigger than just us. Yeah.
But I think this definitely falls in that category of novel suggestions for the editors and journal publishers that we could keep on the docket for tomorrow. Please.
Silverberg at INDS. I wanted to make two comments. One, going right after Brian, is about what papers look like in high-profile journals now. You're required to have so many different techniques and angles of how you do things to be acceptable. If you compare it to papers published 50 years ago, where it was a single little thing, and they said, look what we found. And what that means is that, first of all, we expect that every investigator will have all these expertise under their belt, which is totally unrealistic. And that's why we end up with these collaborations, and not everyone really understands what the other one is doing or can evaluate it critically. But more importantly, the reviewers can't either, and because they don't have all these expertise. And this already, we had this discussion in the 2012 workshop, and one of the ideas that was brought forward is to have multiple reviewers. You have reviewers who are experts in every area. So you can imagine, Steve Goodman being asked to look at the statistics of a particular paper, and then don't go read the whole paper and evaluate how they did the imaging and so on, but give us your thoughts on did they use the right kind of statistics in doing the study, and for each one of these different domains, or to stop asking them or expecting them to have all these different disciplines in the papers. So not asking for that last figure of animal studies. And there's a very interesting retraction. This is somewhat to what you said, Brian. There was a retraction report. I picked up this paper. It was in a high-profile single-name journal. It was retracted based on figure 7F, which was an animal experiment, which I'm sure they had to add at the very end. But the whole paper, which had dozens of panels, was retracted based on this one little last thing. So you have to ask yourself, if we're putting so much emphasis on that last one thing that, this is what's going to determine whether we accept it or not, then you can see where the biases and issues come in. And my second comment is Harvey's to what you said about rigor and transparency. In my mind, they're one and the same. In what sense? If we focus on transparency and require transparency and make sure that work is transparent, it'll lead to rigor. No one wants to say, I didn't blind, I didn't randomize, I have no clue how I came up with the sample size. No one wants to do that. So they might be forced to, in the first time they submit to a journal that requires that information. And the journal doesn't say you have to have done it, you just have to report on it, okay? So I strongly believe that transparency will lead to much greater rigor.
Thank you very much on both comments. Please.
Alexa McRae, Harvard Medical School. Shai made exactly the comment that I was going to make, exactly the comment. And Benedict also had foreshadowed that in his remarks, is that these two things go hand in hand. I would say, transparency and rigor are two sides of the same coin, because it allows the broader community to assess and to weigh in. And that speaks to the burden issue as well, because if you are transparent early on and are continually transparent, then a lot of these other things are no longer burden, because you're not trying to fix something that you did wrong in the first place. And so I'll just end with saying again that the reason that we called our report, our consensus study, Open Science by Design, is that you design your science early on to be open, to be reproducible, and all of those things. And it's not just, it's at every single point of the research cycle where you are being open and transparent. And as we say, if you want to get credit for your work at any point on that cycle, make sure that your data and methods and so forth are openly available, and take advantage of all of the tools and capabilities of the digital age, because as I've said to many people, society has been revolutionized by the digital age. Nobody will argue with me on that. Science is lagging, and with all of the opportunities that the digital age offers. So it's a comment. I don't know that you need to respond, but.
Very helpful. Thank you so much, Alexa. Please.
Hi, Deborah Sweet, Cell Press. This is prompted by what you said, Benedict, about you.
Briefly for the record, yeah.
Again, Deborah Sweet, Cell Press, prompted by Benedict. You said something about how when you review a paper, you find going through the methods really boring, and you don't.
No.
You sort of said it's burdensome.
burdensome, but I always go through the methods. Yeah, yeah.
But something we've been talking about and trying to encourage, I often think that the best people to look at how the experiments were done and whether the information is actually sufficient to understand how they were done and potentially reproduce them are the people in the lab actually doing the experiments, the students and postdocs. So, and one thing we've also been encouraging is to, as a training exercise, to involve students and postdocs in the review process. So we as journal, we could do this. You could do this, we could do this. Encourage the students and postdocs specifically to look at that and make that part of the review that comes back. It's just come back, does this give you enough information to really understand how this was done? And if we did that, then that would help. Because I thought about when you said about having a methods review before it even goes out for formal review. Great idea in principle. I don't think many authors would be very fond of that. Your paper's been held up for 3 weeks by methods review. They're like, what? So, but if you did it the same in that way, maybe it's a way that we could get it into the process more.
Yeah, I'd like to comment too. We started today with definitions of reproducibility and replication, but we never really defined transparency. And I guess an assignment I would give to everybody, we have small groups tomorrow, is think about what a 100% transparent paper would look like. What would that mean? What would you absolutely want in 100% if you don't care about how much time it takes to review it, put it together, et cetera? I think that would be an interesting exercise for discussion tomorrow. But otherwise, I totally agree, and I use my postdocs exactly for that. So, yeah, yeah, of course, yeah.
We have time just for two other brief interjections and comments.
Discussion, and I was sitting there thinking, a couple of years ago, about Arturo Casanova, a couple of years ago, we actually looked for a definition of rigor, and we could not find one. In fact, we wrote a paper on it. The NIH came up with a definition of rigor, but if you read it carefully, some elements of it are circular. And I would point out that I think this issue of transparency and rigor is a fascinating discussion. And there is clearly transparency can promote rigor. But I would urge you to think that the two are really different, as you pointed out. And I give you just one example. You could do highly rigorous atom bomb research in secret. And whether it works or not is whether the bomb works, right? So in a way, you could do the research totally without any transparency. It could be highly rigorous. But what you're really saying is that if you open it up, that could itself promote rigor independently of the tenets that define rigor. And I think that's a very, very important distinction to come through.
Thank you for that added perspective. And the last word.
Interesting that you say that, because I was actually going to make a contrary comment. Steve Goodman, Stanford. So I was just going to make the point that I actually thought that the rigor and transparency were inextricably connected and couldn't be separated. We don't have the atom bomb example because we, in fact, often don't know the truth. So the only surrogate for truth we have is the number of scientists who agree, who believe that what you're demonstrating is true. In fact, you look in philosophy of science books, that's how they'll define a fact. Things that everybody agrees is true. We could get into more in philosophy. So the problem is that if it is done rigorously, but it is not transparent, we've learned that we can't trust science that we can't see. And that we've seen too many examples of things that were done rigorously or not done rigorously. But if it's not transparent, we've learned, unfortunately, by example, that too much of it is not reproducible. That's been the bomb explosion. The bomb has been the non-reproducibility. We wouldn't be here today if there weren't demonstrable examples of research that did not translate, or research that didn't carry through with phenomenon that we could confirm. So they're inextricable in the sense that we're not going to convince anybody that a claim is true, no matter how rigorously it's done, if it's not transparent. And so therefore the science won't perform its purpose, which is to garner a consensus. And that people will be confident enough to act on it. So in that sense, they're two sides of the same coin. Stop there.
This is a fascinating discussion that I know we could very profitably carry on for quite a while this evening. Fortunately, we have reached our concluding hour, however, and Benedict has given us one assignment, which is think about the meaning of transparency. Whatever you feel is the relationship between transparency and rigor, we still, I think, could very usefully follow that advice. I might also ask, as an overnight thought experiment, if you think of each of the 4 key constituency, recognizing, as we heard in the previous session, that there are many others that are relevant and important, but of the 4 key ones that we're going to think about expressly tomorrow, what in your mind would be for each of them the one most important thing that you would bring for consideration to the publishers and journals, to the funders, to the institutions, and to the research community itself? If we each think of that, I think we'll get a great head start on our work tomorrow. We're going to begin in the morning hearing from Marcia McNutt, the president of the National Academy of Sciences and former editor of Science. We'll also have a chance for one additional roundtable, and then we'll be breaking up into small groups to come to grips more particularly with these suggestions and ideas for our 4 key constituents. So I hope everyone has a very enjoyable evening. Is there anything else I have forgotten to mention? No, not that readily occurs. Thank you all for your active participation through the day, and join me in thanking our final panel. Thank you.